One of the real key questions in our field of volcanology is to try to understand when is a volcano getting ready to erupt, and when is something that we observe happening there just a natural process that isn't going to lead to eruption.
Deformation is often one of the first signs that a volcano is becoming restless, and then we also look for increased seismic activity. But the earlier that we can detect that deformation, the more we can refine what kind of a forecast we have and whether or not we need to be concerned about eruptions.
NISAR has a couple of capabilities that are going to be really transformative for volcanology. The first is the consistency. The fact that we're going to get these incredible data very consistently every couple of weeks. The other aspect of NISAR that's very important is its wavelength. It's got a longer wavelength than most satellite missions that have taken radars up into space. And that longer wavelength means that we're going to be able to penetrate vegetation and be able to see the ground through trees. We're going to get consistency, and we're going to get the ability to see through a lot of this obscuring vegetation. And that's really going to open the door for studies of volcanoes.
Because it's expensive and dangerous to put ground sensors around many of the world's volcanoes, many volcanoes around the world have no sensors on them or too few sensors to really understand what's happening.
Having something that's completely remote and satellite-based allows us to get an image of what's going on without needing to have something in the remote ground surface.
The thing about volcanoes is they could have a regional or even a global impact depending on the size of the eruption.
So it's really key to be able to understand how volcanoes work so we can better forecast their activity and warn people that might be impacted by eruptions.